Hi, my name is Rashik, and today I am going to demonstrate a graphical user interface developed in Python for generating texture features and predicted density color maps on the tumor ROI of a user selected slice of a user selected patient. I'll run the code for you. This is the GUI. The first step to perform is to select the input file directory. So we have to go to the location of the dataset, select the folder. Then we have to select the patient which we want to consider. So let's say we select the JTY patient. Then select the corresponding slice. Select the contrast. So we have 6 options available here. Let's select EPI contrast for now. We have 4 texture analysis algorithms available. So I'll just click on the raw for now because raw features will be able to generate quickly. If I select all of the 4 or maybe 2 or 3, it will take more time. Then on the right side we have various parameters which will be passed to the texture analysis algorithm. So we can select the GLCM distance, some value, let's say 2. Similarly for LBP radius we can select out of these 3. Let's say we select 1. For Gabber parameter it's empty as of now, but we will be adding values soon. The next step to perform is to set the output directory where we want to generate the texture feature file. Let's say I select the, I've created a lab results folder here, so I'll select this folder. Let's make sure it's empty. I just have one file which I'll explain later. So for the EPI file, we will give it some name. Let's say EPI_1.csv. When I click on this generate output file button, what will run in the backend is that our algorithm will place a 8 by 8 pixel sliding windows on the tumor ROI and extract the user selected texture features for each window. So when I click on this, the algorithm ran in the background, as you can see in the terminal, and it finished, and the message is displayed, file generated, and the file has been generated in the output directory, that is our lab results folder, as you can see here. So if I can open this up, you can see the phase which we selected, and since we only selected raw features, so the corresponding raw mean and raw standard values are there. If we selected all 4 or maybe 2 or 3, then there would be more features here. Let's close this down and let me make sure the recording is going on. Yes, it is. So similarly, I will select other contrasts one by one and generate the files. Let's give it a name. The file is generated. As you can see in the background, the file is generated. Similarly for other contrasts, I will give username q_3, and you can see the file is generated. So the user can do it for all the contrasts which are available. So we have generated 6 texture feature files corresponding to the 6 contrasts which are available in the GUI. Coming to the bottom half of the GUI, as you can see, we have provided 6 buttons here. Other buttons for generating texture maps can be added in the future. When you click on a particular button, what happens at the back end is that our algorithm searches for the texture feature file corresponding to the contrast button in the output directory scans the file for the raw mean feature values and superimposes it on the patient's DICOM image as a color map. So say when I am selecting this button, it will search for the EPI keyword in all of these files available here and give me the corresponding color map. Let's see. So this is the color map for EPI raw mean feature map. The color bar alongside shows the correspondence between different colors and the values of the feature. So let's generate the color maps for the other modalities. Let's say P modality, P raw mean feature map, Q, and similarly for others. I have provided a button generate all raw feature maps, which when clicked gives me simultaneously all of the 6 raw feature maps. Let's click on this, and as you can see, it gives me all the color maps simultaneously. This provides a facility to the user to compare all the maps alongside and compare the different maps in the different color map values in the different regions of the brain for the different modalities. Let's close all of these down. Let me make sure the recording is going on. Yes. Coming to the final portion of the GUI, I have provided 2 buttons, generate PI color map and generate predicted density map. So when this button is clicked, what will run in the backend is our MLPI model will take the generated texture feature files as input and generate a prediction for each sliding window. So right now in the output directory, I have this JTY slice 15 prediction file, which is already created. And for this patient, we have all the PI predictions as well as the MLPI predictions already created. So just to save time, the file is already created and located here at the output directory. And in our GUI, when I click on the generate PI color map, based on the PI prediction column, it will give me the corresponding color map. See? And all the predictions are ranging from 0 to 1. Similarly, for the generating the predicted density map, it will take the values from the MLPI column. In the future, we can embed these 2 maps right here. Thank you for your time.